we're going to enter something of a heavy section of this course, and that is dealing with fractions, heavily into fractions. And in this section, we're going to look at mixed numbers and how to turn them into fractions and how to turn fractions back into mixed numbers. So anytime any improper fraction can be turned into a mixed number. So I'll show you how that's done. This example is meant to help with that. Let's convert 27/8 into a mixed number. Now, when I'm talking about an improper fraction, I mean that the numerator is bigger than the denominator. So the way you do this is you use long division. And so I'll put 8 and go into 27. 8 goes into 27 3 times, with a remainder of 3. So what this means is that the fraction 27/8 equals 3 3/8. So let me put this here. The number on top of the division bar is the quotient, and we have the remainder. This wasn't the best example to use because I happen to have the same remainder as a quotient, but let me point them out here. The quotient is out front, and the remainder is up there. Let's do another example. So if you haven't done long division in a while, you'll have to brush up for these particular examples. Let's convert 79/3 into a mixed number. So I'm going to do long division. 3 goes into 79. I'll start 3 goes into 7 twice. And then 3 goes into 19 6 times. We have a remainder of 1. So all this means is that 79/3 equals, put the quotient first, so there's 26. The quotient goes first, and then the remainder goes over the divisor. That was a 3, not an 8. All right, so let's get this, make sure that we have this. Quotient, quotient. Then I have remainder, remainder. Then I have divisor, divisor. Let's do a few more examples. Next, let's convert -37/4 to a mixed number. Ignore the negative. You'll simply apply the negative to the end result. So while we're doing the actual division, I can absolutely ignore the negative because it's unimportant as far as this is concerned. The negative isn't even figured while you're converting to or from a mixed number. The 4 does not go into 3, but it does go into 37. It goes in there 9 times with a remainder of 1. So -37/4 equals 9 1/4, except don't forget the minus sign. So you don't have to worry about the negative until the very end of the problem. You just attach it at the end. Now, to convert the other way, that is to take a mixed number and convert it to a fraction looks like this. We'll start with an example. I'll do more explanation than is probably necessary, but I want you to get the idea behind it. So let's convert 6 2/3 to an improper fraction. So on the one hand, you know that you should get a fraction whose numerator is greater than the denominator. So the way this works is the following. You may not have known this, but 6 2/3 is the same as 6 plus 2/3. So that's the same thing as 6 2/3. The plus sign has simply been squashed or hidden from view just because it makes the notation a little bit nicer. But keep in mind, nonetheless, it is an addition sign in between the quotient and the fraction. So like you would anything else, if I'm going to do this, I'm going to write 6 over 1. Then I'm going to notice that the LCD equals 3, and I'm going to convert both of these fractions to be over 3. Now the beauty of this is the second fraction is already done, and the quotient part, the 6, was very simple to do. If you look, in order to change a 1 into a 3, I had to multiply by 3. 6 times 3 goes into this blank spot. So that's 18. So 6 times 3 equals the 18. That's how I got that. And then I'm ready to add them together. Since they have the same denominator, this is 18 plus 2 over 3. And that's 20 over 3. And that's all there is to it. So converting back to an improper fraction, I think, is easier than making a fraction into a mixed number. This direction seems easier to do. Let's do another example. Let's convert 17 2/5 to an improper fraction. So same deal. I have 17 over 1 plus 2/5. And the LCD is very simple. Whenever one fraction has a denominator of 1, the LCD couldn't be easier to find. It'll be 5 this time. So I'm going to convert both of my fractions to being over 5. The second one is already done. Once again, 1 times 5 gave me the 5. I have to do 17 times 5. 17 times 5 is 85, and that goes up here. And then when I add them together, 85 plus 2 is 87 over 5. Let's do a negative one. Let's convert -3 5/8 to an improper fraction. Pay attention to what I'm going to do here. People make a mistake on this a lot. So let me write this down. Ignore the negative sign. For now. We'll simply put it at the end of the problem. So I'm going to have 3 over 1 plus 5 over 8. My LCD is 8. So I'll write both fractions as being over 8, with the 5 already done. 8 times 3 is 24. So I'll get 24 over 8 plus 5 over 8. And that will give me 29 over 8. Now we're not done. Now is the time to put the negative. So my final answer is the following: negative 29 over 8. So simply put the negative sign at the end of the problem. Be careful. A lot of students make a mistake of, especially this part here, if you keep the negative attached to the 3, when you add them together, it's going to mess it up completely. So do not use this. This warning is important. Ignore the negative sign until the end of the problem. That's when we're converting between mixed numbers and back again. Now, mixed numbers are easy to visualize. For example, give me a minute, I'm going to do 3 of these boxes. And forgive my writing, but they're all supposed to be of the exact same size, and all these little squares are supposed to be the exact same size. So I'm going to shade in 2 squares completely, but then this one I'm going to just use some of it. So all in all, you could use this to represent 2 whole pieces and then 3/4 of a whole piece. So that's one way you can visualize them. Another way, you can draw any kind of pictures you want. It really doesn't matter. My circles are changing size on me, so just be careful on that. These are all supposed to be straight lines too, but I'm hoping you can handle the confusion. What I'm doing is cutting these like pizza. 8 slices, equal slices, supposedly equal slices, if I can draw them right. So in this way, let me shade 3 of them completely. Use different colors if you want to, I suppose. I'm going to do half of it, but I'm going to do a little bit more than half of it. That piece will be in there as well. So in this way, I've got 3 whole pieces shaded, and I've got 5/8 of a piece shaded. So I can simply visualize this as 3 and 5/8. So mixed numbers have uses like that. They're also very easy to organize them on a number line. So as an example, let me show you here. Let's graph the following numbers on a number line. Here I have 4 and 1/3. Then I have -1 and 5/6. I'm separating them with commas. 2 and 1/2. -3 and 1/4. And -4 and 3/8. Now, this doesn't have to be exact, but we do want them arranged appropriately. So let me see if I can get how long I can make my line. Probably way longer than I need to, but I think I only need to go 5 in each direction will cover what I need. So we'll have 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So let's start with 4 1/3. 4 1/3 is going to be between 4 and 5. So it's past 4 by 1/3. So try to estimate 1/3 of the way between 4 and 5. And in that dot there, you get 4 1/3. So like I said, it doesn't have to be exact, but you can at least see quite clearly where these things, about where they're at on a number line. Let's go to the next one, -1 5/6. It'll go to -1, but the 5/6 that's attached to it will push it closer to -2. In fact, 5/6 is almost a whole number in of itself. So this is slightly less than -2. So I'll put it right about here and put -1 5/6 representing that dot. Next, 2 1/2 is really simple. Just go right between 2 and 3, and I get 2 1/2. -3 1/4. Go between -3 and 4, and I only want to go 1/4 of the way between -3 and 4. So try to estimate 1/4, and then we have -3 1/4. Finally, -4 3/8 is going to be between -4 and 5. 3/8 is a little less than half. So I'm going to put it a little less than the halfway point here. And there's -4 3/8. So these are very easy to compare with each other. The point I'm making is that mixed numbers have lots of uses. But when you're working with them, it's best usually not to keep them as mixed numbers. They are meant for display purposes mostly. Like I've written in the last few steps here, pictures or graphs, or to be used to describe something. But to work with them, it's awfully difficult to work with mixed numbers in their mixed number format. Let me show you what I'm talking about. When I'm doing multiplication, say I want to do 2 1/6 times 4 2/7. Now what I'm going to do right now is I'm going to show you what some students do and why it's wrong. What we have is the following. Students sometimes will do 2 times 4, and then they'll do 1/6 times 2/7, like this. And they'll get 8 plus, and then when you multiply these together, like so, you get 2/42, but I can simplify this a little bit. So I'll get 1/21. What I just did here is all wrong. The way you multiply is not like this at all, and you'll see when I actually do an example of this. I'm not exactly sure what I want to do as far as explaining it to you, but let me at least do this. If you were thinking of this, you are all wrong. Let me go back to black. Let me show you the way that you should do it. If you were to actually try to multiply it out like in this format, you would have to recall something called the FOIL method, which would involve 4 multiplications total, and then you add them all up and you get your answer. So doing what I showed you was absolutely wrong because it did not use the FOIL method. You're not required to have knowledge of the FOIL method in this class. So then how do we expect that you do this multiplication? What we do is we turn these into fractions. And this is where the practice with converting between mixed numbers and fractions is very important, because if you got to spend a lot of time doing that first, the whole problem is going to seem very arduous. I'm going to start with 2 1/6. What I did before, where I got the 2 and wrote it over 6, you can do that. Another way to do it, this is the way I was shown in school, is I would take the 2 and multiply it by the 6, and that would give me 12. And then I add it to 1. So what I'm going to say, let me write this, 2 times 6 plus 1 over 6. Same deal here. 4 times 7 plus 2. So getting a common denominator, it's done all in one step in this fashion. Now let me fix this up before I actually do the multiplications. I get 13 over 6 times 28 plus 2 is 30 over 7. Now before I multiply, like anything else, you should want to get your answers in simplest form. So I will cancel if I can. Now as I look through this, 13 is a prime number, so nothing's going to go into it unless there was something that went into down here. So nothing happens there. However, the 30, between the 6 and the 30, I can cancel out a 5. So now when I multiply these together, I'll have 13 times 5, that's 65. And then 1 times 7 is 7. Generally speaking, if you're given a problem with mixed numbers, they'll want you to write your final answer as a mixed number. So right now, while 65 over 7 is correct, this is a correct answer, I might want to write my final answer as a mixed number. So I go 7 into 65. And 7 doesn't go into 6, but 7 goes into 65 9 times. And so the answer that I want is, remember, quotient and remainder over divisor. So most likely they'll want your answer as a mixed number because the original problem was in terms of mixed numbers. So let's do some examples multiplying, and I'll try not to spend as much time doing them. I'll just go through most of the steps. So I have 7 1/3 times 1 1/6. Start with the 7 1/3. Now remember, you do 7 times 3 is 21 plus 1. You get 22 over 3. And do the same with 1 1/6. 1 times 6 is 6, plus 1 is 7. Then I'll simplify as much as I can before I multiply. 6 and 22 both have a 2 in them, so I can cancel out that. Then I have, I'm going to put my equals up here too. Then I have 11 times 7, that's 77. 3 times 3 is 9. And then let me finish it off with the mixed number version of it. So 9 goes into 77. Let's see, 8 times with a remainder of 5. So my quotient is 8, my remainder is 5, and my divisor is 9. So I don't know if this helps you. Quotient, remainder, divisor. QRD. If that helps you, fine. Just remember it in that order. If you mix any of them up, it's going to destroy the whole problem. Next I have -3 2/3 times 6 3/11. Now one thing you know, you have a negative times a positive, so your final answer is going to be negative. Don't forget that. So if you're going to write your answer, put a negative weight for you, whatever. Now when you convert this mixed number to an improper fraction, ignore that negative sign. So +3 times +3 is 9, plus 2 is 11. So I'll keep the negative there, 11 over 3, but it was not involved in the computation. Similarly, 6 times 11 is 66, plus 3 is 69. And, well, this is nice. Notice that the 11s cancel out. And, in addition, if you take 6 plus 9, that's 15. 3 goes into 15, so we know that 3 goes into 69. How many times? It goes into 6 twice. Bring down the 9. It goes into 9 3 times. So this equals negative This goes in there 23 times. So when all is said and done, we just have negative 23 over 1. Well, considering that's the problems that were involved, that's a very simple type of an answer. Next, 12 times 1 3/8. Once again, I'll change this mixed number here to a fraction. 1 times 8 is 8 plus 3, so I get 11 over 8. To make this 12 work with us, I'm going to rewrite it as 12 over 1. Now remember, you don't need a common denominator when you're multiplying, only when you're adding and subtracting. But I will do some canceling here. Notice that 4 goes into 12 3 times and 4 goes into 8 twice. So I'm left with 3 times 11. And then I have 1 times 2. And then let's change my final answer to a mixed number. 2 goes into 3 1 time. 2 goes into 13 6 times. And we have a remainder of 1. So quotient, remainder, divisor. Last multiplication, we have negative 3 3/4 times negative 7 over 30. Now, I have a negative times a negative, so the negatives completely cancel out. So I'm going to just not write them for the rest of the problem. I know my answer is positive. Let's start and change 3 3/4 to a fraction. So I do 3 times 4 is 12, plus 3 more is 15. So I get 15 over 4 times 7 over 30. Notice all the negatives are gone. Now 15 goes into 30 twice. And I think that's all we have. So I'm going to get 1 times 7, and then 4 times 2. Well, there's not a whole lot you can do here. You can't rewrite it in any way. It's a proper fraction, and you're not going to be able to do anything with it except just leave it like that. So we had our multiplication. Next, division. With all the problems, I hope you see that what I'm trying to do is before I do anything with mixed numbers, I always rewrite them as fractions first. Always. And then I do the problem. So let's start with some examples and I'll show you what I mean. 4 1/6 divided by 1 1/9. I'm going to do like I do every problem. Turn it into a fraction first. Start with the 4 1/6. I'll do 4 times 6 will be 24 plus 1. And then the 1 1/9, I'll go 1 times 9 is 9 plus 1, so I have 10 over 9. Now I'm ready to do the problem. So first, change it to fractions, then work the problem. Remember, when you do division with fractions, you multiply the second fraction, or you take the reciprocal of the second fraction and you multiply. Now there's a lot of stuff that will cancel. For example, 5 goes into both 25 and 10. Additionally, 3 goes into both 6 and 9. So when all is said and done, I have 5 times 3, so that's 15 over 4. And I'll finish it off by finding out what that is as a mixed number. 4 times 15, 4 goes into 15 3 times, and there's a remainder of 3. So I have the quotient, remainder, divisor. Next, I have -1 5/9 divided by 1 5/6. Now, since I have a negative number divided by a positive number, the answer is negative. I know that already. I can ignore the negative throughout the whole problem, but I just need to remember to put it on the end. And I'm going to keep writing it just so I don't forget about it. Let me change everything to fractions. 1 times 9 is 9, plus 5 more is 14. So I get 14 over 9 divided by 1 times 6 is 6, plus 5 more is 11. And then let me turn the second fraction upside down. And now let's cancel. The only thing that I see that cancels is 3 goes into both 9 and 6. So let me cancel it out. "14 times 2 is 28. And the bottom is 3 times 11. Well, whenever the numerator is less than the denominator, you know you're done. Next, I have 7 2/3 divided by 10. Don't freak out. Think of that 10 as 10 over 1. Let me start and convert the 7 2/3. I have 7 times 3 is 21, plus 2 more is 23. So I have 23 over 3 divided by 10 over 1. Now it's just like any other problem that we do. I'll have 23 over 3 times 1 over 10. Take the reciprocal of the second fraction. Nothing cancels, so I'm just going to multiply straight across 23 over 30. And I'm all done, because the numerator is less than the denominator. Next, I have 10 divided by -4 2/3. Once again, my final answer is going to be negative, so I just have to remember to keep the negative involved in the whole thing. So what I'm going to do is just put the negative out front. The 10 I'm going to change to 10 over 1. This mixed number here, let me change it to a fraction. 4 times 3 is 12, plus 2 more is 14. So I get 14 over 3. And this changes to -10 over 1 times 3 over 14. Now, there's not a lot of simplifying here, except between 10 and 14, 2 goes into both of those numbers. 2 goes into 10 5 times, 2 goes into 14 7 times. So I get 5 times 3 is 15 over 7, and then I'll finish it off by writing this as a mixed number. So I have the quotient, remainder, divisor. As is usual, the most complicated stuff involving fractions is addition and subtraction, because you have to get common denominators. Let me tell you what we're doing here. Addition and subtraction. There's more than one way to do addition and subtraction. I'm going to show one way. Your book advocates for 2 ways. I'm only going to go with one. You do what you want to do. But I'll show you what they're talking about, and then I'm going to do it my way for the rest of the problem. So let's start with 5 and 8 over 13 plus 4 and 3 over 13. What I'm going to do is convert them both to fractions. So start with the 5 and 13, or 5 and 8 thirteenths. I do 5 times 13 is 65, plus 8 more is 73. Do the same over here. 4 times 13 is 52, plus 3 more is 55. So I need to add 73 and 55. And I get 128 over 13. And then to finish off the problem, I'm going to take 13 into 128. And I'm kind of stuck because 13 doesn't go into 12, but I don't know how many times it goes into 128. Let me try 9 times 13. Okay, so it's 9 times. So we have 9 and 11 over 13. Make my 9 better looking. I still don't like the 9, so I'm going to erase it and make a better looking 9. So convert to fractions first, but redo looks like this. If you wanted to, I've seen some people do 4 and 7/16 plus 2 and 1/8. This is the way I've seen students do it. They'll stack it like this. And then they'll have the 7/16 and they'll have the 1/8. Now they realize that adding over 16, having an 8 and 16 as a denominator, the LCD is 16. I think I said a redo when that's not true. This is a whole nother example. But I wanted to show an alternate way of doing these problems. But this isn't the way that I'm going to do them. What they'll do is this. They'll write this. The 7/16 will be fine. But the 1/8 they'll change to 2/16. Now then when we add them, I can add the columns up. So like the 7/16 plus the 2/16 will be 9/16. And then 4 plus 2 will be 6. So you get 6 and 9/16. That's another way to do it. I will not do any of them like that. If you want to do it that way, that's perfectly fine with me. I will understand it. But there's some complications that you're going to have to be aware of, especially when you add the 2 fraction parts and they turn out to be bigger than 1, then you have carryover. Or when you subtract, it's even worse. Let's do 12 and 5/9 minus 3 and 2/27. 12 times 9 equals 108, plus 5 more is 113. Over here, 3 times 27 is 81. 81 plus 2 is 83. Then when I do the subtraction, I get, well, I made a mistake. I was all set to go, but I forgot the other denominator is over 27. The LCD is obviously 27. 9 goes into 27 3 times. So I'll change the first fraction so that it has a 27 in the denominator. What do I got to do? To get 9 to be a 27, I had to multiply by 3. So I've got to do 113 times 3. And that's equal to 339. And then let me do the subtraction. So I'm going to have 339 minus 83. It looks like 256. And then I need to convert that to a mixed number. So let's take the 27 into 256. I think it goes in 9 times. Let me do 9 times 27. $243. So 9 That'll leave a remainder of 13. So the quotient is 9, the remainder is 13, and the divisor is 27. Next I have negative 6 3/4 plus 1 1/9. So let me first put these as fractions. Remember, ignore the negative while you're converting. 6 times 4 is 24 plus 3. I have 27 over 4 with a minus in front of it. Over here, 1 times 9 is 1, plus 1 more is 10. The LCD here equals 36. It's easy to do that because the only things that go into 4 are 2's, and the only thing that goes into 9 are 3's. So you're going to have to do 4 times 9, or 36 is your LCD. So both of these fractions will be over 36. So let's start with this one. To change a 4 into 36, I had to multiply by 9. So 9 times 27. Did I do that one up there? Look at this. Isn't that cute? 243. And then the other one's easier. To turn 9 into 36, I had to multiply by 4. 4 times 10 is simply 40. Now, when you do this problem, I recommend that you attach the negative to the numerator, like so. Then I know it's negative 203 divided by 36, and then I'll do the long division. Once again, ignore the negative while you do this, but put it down because don't forget it's there. So 36 goes into 203. Once again, 36 does not go into 2, it doesn't go into 20, it only goes into 203. How many times? Well, I have to estimate. I believe if you do 6 times 36, it's too much, I believe. Yeah, that's too much. So I'll have a 5 with a remainder of 23. So negative 5 and 23 over 36. So you can see this is some heavy material. Moving on. But please remember to change all of these things to fractions before you do anything else. Let's start with the 13 7/8. Well, 13 times 8, how much is that? That is 104, plus 7 is 111. So I get 111 over 8. Over here, 5 times 6 is 30, plus 5 more is 35 over 6. So I'll attach the negative to the 35. Now what's the LCD between 8 and 6? You can work that. Remember, 8 equals 2 to the third. 6 equals 2 times 3. So when I make up my LCD, you're going to need 2 to the third times 3, and that equals 24. So I'll change my denominators to 24. Starting with 8, turning into 24, I had to multiply by 3. 3 times 111 is 333. Similarly, to turn 6 into 24, I had to multiply by 4. 4 times 35 is 140. Now I'm ready to add them together. So when I do 333 plus negative 140, it looks like I will end up with 193 over 24. And then I'll change that to a mixed number. And like so many of these other ones, the division is just plain one shot because 24 doesn't go into 19. I have to try to figure out how many times 24 goes into this thing. So I'll start with, let's start with 7. There's 7 times 24. Let me do 8 times 24. Ooh, nice. 8 goes into there almost exactly. So we end up with 8 and 1 over 24. Then let's look at some odd mixed numbers. Let's write 1 and 11/8 in simplest form. This is not a proper mixed number because the fraction part of it has a numerator that's bigger than a denominator. Nonetheless, what I'll do is use the process that we have to change it to a fraction. So I'll do 1 times 8 is 8, plus 11 is 19. And then I'll write that as a mixed number, and that's simplified. That's considered simplified. And it looks like we have 2 and 3/8. That version is simplified. Let me show you something else. One thing you could have done is this. You could have done this. Basically what I did here, when I took this 8 over 8 out, that's 1. So if you will, I didn't factor 1 out, but I pulled a 1 out of there. So this is 2 plus 3/8, which we simply write as 2 and 3/8. Let me make my circle bigger. So there's more than one way to do that. Once again, I advocate for just one way because that's the way I'm going to do all the rest of the problems. So I'm going to write 7 and 19 over 10 in simplest form. Once again, let me change it to a fraction. 7 times 10 is 70, plus 19 is 89. And I will leave this process up to you. This is 8 and 9/10. Next, let's do 11 minus 10 and 2/5. If you're sharp and you're paying attention, you'll know that this answer is going to turn out to be 3/5 just by looking at it. Because 10 and 5/5 would be 11. I would need to add 3/5 to get to 11. So this just equals 3/5. However, if I redo it, I would change that 11 to 11 over 1. This mixed number, 10 times 5 is 50, plus 2 more is 52. Then the LCD is 5. And so I would get 55 over 5 minus 52 over 5. Now you can see that you're going to get 3/5. Last couple of examples I want to do involve word problems, and they come right from the textbook. These are out of 3.6. Let me start with the picture, and I'll make it bigger in case we need. You will find mixed numbers quite often used in medical settings, so this is not unusual. Now what I want to do is problems 116 and 118. Let me go in your textbook and find number 116 and copy it in here. And I want to do 118 too, but let me do 116 first. I think if I copy, let's put it over here. And I'll see if I can make it any bigger. Move it over. And then make it big. All right, so problem number 116. How much weight did the patient lose from day 4 to day 7? So there's day 4. They weighed 144.5 pounds. Day 7, they weighed 139 1/3. So we want to do 144 1/2. That's day 7. Actually, that was day what, 4? Minus day 7 was 139 1/3. Let's go ahead and do this computation then. I'll start with this one here and change it to a fraction. 144 times 2 is 288, plus 1 is 289. Over here, 139 times 3, I think is 417. 417 plus 1 is 418. Now the LCD is 6. So I'll rewrite each of these fractions to be over 6. Well, in order to change this 2 to a 6, I had to multiply by 3. So I've got to do 3 times 289. I'm going to need more space here. I believe I'll get 867 over 6. And then to change the 418 over 3 to being over 6, I had to multiply by 2. This is easier to do. I'll get 836 here. So when you do it, all I got to do is worry about the 867 minus 836, and that's 31. And that is 5 1/6. So let me check my numbers. 144.5 minus that. So it's a little over 5 pounds. 144 minus 139 is 5. So 5 1/6. That's not the answer, though. Your answer is 5 1/6 pounds. Now let me go ahead and grab number 18 or 118. I'll tuck it in and down here, I think. And let me resize it. I don't want to block my work from before, so that should be enough. All right. Over the 7-day monitoring period, did the patient gain or lose weight, and how much? Well, they started at 141 2/3, and they went down to 139 1/3, so they lost weight. So how much did they lose? We've got 141 2/3 minus 139 1/3. I'm going to take this opportunity to do this in that one special way because everything lines up so well that you can't help but want to do it. I only recommend this when things are really, really nice. 2/3 minus 1/3 couldn't be better. 141 minus 139 couldn't be easier. And then all I have to do is add my pounds, and there we are. I want to do another example, another word problem type of an example. And that is number 124. Actually, it may not be a word problem, it's just a different style of problem. Let's see. There we are. Mark it off from the rest. And let me make it bigger. All right, there's two parts, an A and a B. Let's start with A. We have somebody, Aracelli's sewing project needs 3 pieces of fabric, and there they are. What's the total amount of fabric that she needs? I just add them up. So I'll do 3/4 plus 2 1/2 plus 4 1/3. I'm going to change everything to fractions. So I get 3/4 plus 5/2 plus 13/3. I'll leave it to you to come up with the reasons behind those. The LCD is going to equal 12. The 3/4 I'll be able to write as 9/12. The 5/2 I'll be able to write as 30/12. And the 13/3 is 26/12. I made a mistake on that last one. That's not true. It's still over 12, except 3 times 4 is equal to 12. 4 times 13 is 52. My bad. Now I'll add these numbers straight across. 9 plus 30 is 39, plus 52 is 91. And then I'll change it to a mixed number. I think it's 7 times. 7 times 12 is 84 with a remainder of 7. So we would have 7 7/12, and this is in yards. So let me put YD at the end to indicate yards. I think I'll be able to sneak part B in over here. How much longer is the longest piece than the shortest piece? So the longest piece is 4 1/3, and the shortest piece is 3/4. So converting the mixed number to a fraction, as before, I have 13/3 minus 3/4. The LCD is once again going to equal 12. 13/3 is 52/12. 3/4 is 9/12. I end up getting 43/12. And that looks like it's going to be 3 7/12 yards.